So, let us have some interactive problem solving sessions by students who have taken this course. So, you will see some illustrations and examples into problem solving which is useful to understand and digest the concepts learnt during the lectures.
So, this problem appeared in MMTSP course in ISC in fall 2016 in the first midterm exam. So, the problem is as follows. Let V be a vector space and suppose W1 and W2 are subspaces of V. You have to show that W1 plus W2 is a subspace of V that contains W1 and W2. So, let us proceed as follows. So, first of all you have to show that W1 plus W2 is a subspace. So, for this you have to prove three properties which are as follows. First of all you have to show that W1 plus W2 is non-empty. So, as W1 and W2 are subspaces, so 0 vector belongs to W1 and 0 vectors belongs to W2 as well. So, therefore, 0 plus 0 vector, which is 0 vector that belongs to W1 plus W2. So, we have proved that W1 plus W2 is non-empty. So, next we have to show that W1 plus W2 is closed under addition. So, for this we proceed as follows. So, let x1 be a vector in W1 and y1 be a vector in W2. So, therefore, x1 plus y1 belongs to W1 plus W2. Similarly, let x2 be a vector in W1 and y2 be a vector in W2. So, it implies that x2 plus y2 belongs to W1 plus W2. Now, let us consider these two vectors x1 plus y1 and x2 plus y2. If we show that the sum of these vectors also belongs to W1 plus W2, then we have proved that W1 plus W2 is closed under addition. So, let us do that. So, the sum of the vectors can be written as and can be rearranged into x1 plus x2 plus y1 plus y2. Now, we know that this x1 and x2, these vectors belongs to W1 and y1 and y2 belong to W2. So, the sum of those vectors will also belong to W1. So, if we so therefore, the sum of the complete thing belongs to W 1 plus W 2. Therefore, so we have shown that W 1 plus W 2 is closed under addition. Now, the next thing you have to prove is that W 1 plus W 2 is closed under scalar multiplication. So, for that let's consider a vector x 1 which belongs to W 1 and x 2 which belongs to W 2. We know that x 1 plus x 2 belongs to W 1 plus W 2. Now, if we show that a scalar multiplication of this to this vector x 1 plus x 2, this also belongs to W 1 plus W 2, then we have proved that it is closed under scalar multiplication. So, let us consider alpha x 1 plus x 2, where alpha belongs to the real field. Now, this alpha x 1 plus x 2 can be written as alpha x 1 plus alpha x 2. Now, this alpha x 1 belongs to W 1 because W 1 is a subspace and it should be closed under scalar multiplication. Similarly, alpha x 2 belongs to W 2. So, the vector alpha x 1 plus x 2 belongs to W 1 plus W 2. So, we have shown that W 1 plus W 2 is closed under scalar multiplication. So, we have successfully proved that W 1 plus W 2 is indeed a subspace. Now, the next thing we have to prove is that W 1 plus W 2 contains W 1 and W 2. So, for that let x 1 be any vector in W 1. So, this x 1 can be written as x 1 plus 0. Now, this x 1 belongs to W 1 and as 0 vector belongs to any subspace. So, this 0 belongs to W 2. So, therefore, this x 1 plus 0 belongs to W 1 plus W 2, which is nothing but the x 1 vector belongs to W 1 plus W 2. So, this implies that any vector in W 1 is also contained in W 2 W 1 plus W 2. Similarly, let x 2 belongs to W 2 any vector in W2, this x2 can be written as 0 plus x2. This 0 vector belongs to W1 and x2 belongs to W2. So, therefore, 0 plus x2 belongs to W1 plus W2. Therefore, x2 also belongs to subspace W1 plus W2. So, any vector in W2 is also contained in W1 plus W2. So, we have shown that W1 is contained in W1 plus W2 and W2 is contained in W1 plus W2. So, we have proved that W1 plus W2 contains W1 and W2. Now, the next thing we have to prove is that, so we have proved that W1 plus W2 is a subspace. We have to show that W1 plus W2 is contained in V. To show this, let us consider a vector x which belongs to W1 plus W2. So, according to the definition, x can be broken down into two vectors, one in subspace W1, one in W2. So, there exists x1 belongs to W1 and x2 belongs to W2 such that x is equal to x1 plus x2. Now, we know V contains W1 and W2. Therefore, x1, x2 this are present in the vector space V. So, as V is a vector space, so x1 plus x2 should also be in V. So, and x1 plus x2 this belongs to W1 plus W2, which is x itself, right. So, therefore, we have proved that W1 plus W2 is contained in the vector space V. So, we have proved, so first of all we proved that W1 plus W2 is a subspace, then we showed that W1 plus W2 contains W1 and W2, and then we finally showed that W1 plus W2 is contained in V. So, this ends the problem.